Hey fellow coders, welcome to Game Dev with Tony. In this video we'll be taking our scriptable objects to the next level by creating a graph system. They'll be used to construct a virtual world of interconnected nodes that we'll navigate through by key press or mouse click, where each node represents a location. We'll be modeling a popular classic game from the 1990s called Myst. Let's dive in. There are a lot of other games that used a world-exploring click navigation system like this, but Myst is the first one I think of. It didn't use a real-time 3D engine. The world was composed of static images to represent the direction you faced: north, south, east, and west. You could move around by clicking the screen. The sides would adjust your direction of view, and clicking up top, if it was allowed, would advance you to the next location and display its image. I want to start off by showing you the game we'll be making in this video, which I've dubbed Polygon Isle. The artwork was generated from a free asset pack, and there's a link to it in the description. We can make 90-degree turns and a 180 by clicking the bottom of the screen. If there's a node connected to the direction we face, then we can move to it by clicking the top of the screen. And you can see the mouse cursor changes based on the screen zone it's in. If you watched my Scriptable Objects storybook video, then you'll remember the fade transition between the pages. I brought that effect into this game. Starting with an empty project. The source code and mouse cursors are up on GitHub and the link is in the description. Unfortunately, I can't provide the world images used here, but what you can do is build your own once you learn how to create the graph. Start with something simple like the interior of your home. Map out your location nodes, then stand in each and take a photo of the 4 directions. So if you ever thought about getting into real estate, you can make a virtual walkthrough. We're going to create 3 folders. Call them Locations, Scripts, and Sprites. Import the mouse cursors to the Sprites folder. Adjust their properties. Make sure alpha is transparency and read-write are both checked. No check on mipmaps. Set the filter type to point no filter and the format to RGBA 32-bit. In the hierarchy, add an empty game object and call it Game Manager. Next, add a UI image, and that'll give us a canvas. Name the image Image 1. Set the width and height to 1920 by 1080. Update its sprite to UI mask or something else, just as long as it isn't solid white. We're going to add a text object and we want to be able to see it. Duplicate the image with Ctrl-D and name that Image 2. In the storybook we used game objects with sprite renderers for the image fades. This time we'll use canvas images. Right-click on the canvas and add an empty. Call it Backgrounds. We'll group our images into it, so select both and drag them in, or you can do them one by one. Add a UI text object to the canvas. Call it Location Text. Anchor it to the bottom center. Hold down the Alt key and click the button. Then do it again but hold Shift. Set its color to white and align the text to be centered both horizontally and vertically. And change its font size to 100. Update the width and height to 1000 by 150. We're going to use this for debugging so we can see our current location along with the direction we're facing. On the canvas, set the UI mode to scale with screen size. Set the width and height to 1920 by 1080. And finally, add another empty game object to the hierarchy and call it Player. That's the scene setup. Next, we're going to create the scripts. In the Scripts folder, create 6 C# scripts. Name them iTransition Effect, Fade Transition, Location SO, Game Manager, Player Controller, and Screen Zone Click Handler. Open them in Visual Studio. The first script is iTransition Effect, which is an interface. If you're unfamiliar with what an interface is, think of it as a contract or a blueprint for a class. It defines a set of members like methods, properties, or events that the class must implement if it claims to use that interface. It specifies what the class should do, but not how it should do it. Our Fade Transition class implements this interface. If we decided to create additional transitions, they would as well. Each class has to define the interface members. Then when you use the interface, you can treat all these different transitions uniformly. Your main script just tells the interface to perform the effect, and the specific transition, be it a fade, cross dissolve, etc., handles the how behind the scenes. The transition effect interface has 4 members and the fade script must implement them. The fade transition script will fade in the images for our directional changes or movement through the world. You can see the class inherits from mono behavior and the interface. We declare 3 serialized fields, the 2 UI images and the duration of the fade. followed by a coroutine and a delegate to notify any subscribers that the fade completed. OnDestroy performs a cleanup when the game object is destroyed. If the fade coroutine is assigned, it's stopped and set to null. Delegate subscribers are removed by setting onFade completed to null. 3 helper functions are declared. The first 2 determine which image is on top or bottom in the hierarchy. In the storybook version, I use sprite renderer swapping and sort orders to make sure the topmost image would fade in above the one below. UI images don't have sort orders, so we check the sibling index instead. The bottommost image in the hierarchy will be the topmost visually displayed. setImageAlpha gets the color property from the image it's given and changes the alpha channel. The original RGB channels are not changed, so you could apply a tint to the image objects if you wanted. setSprite prepares the next sprite to fade in. The fade duration is checked, and if it's 0, we display the sprite immediately. If there's a duration, we get the image objects and take the sprite from the top and then set it to the bottom. Then assign the new sprite to the top, because that's going to fade in, and adjust the alphas on both. The top is transparent and the bottom will be visible. setDuration is a public function, so it can be called from other scripts. The value is clamped, so it cannot be negative. Display immediately can be used to bypass the fade effect. The sprite is set to the top image object and made fully opaque. The transition method starts the fade and accepts a callback. If the coroutine is already in use, it's stopped and then restarted. DoFade is the coroutine that performs the fade effect. We get the images, update their alphas, and force their order in the hierarchy. We perform the fade if there is a duration, incrementing on delta time up to the duration, calculating the new alpha, and then applying it to the image, and yielding on each frame. When the fade finishes, we make the image fully opaque and notify any subscribers that the fade is complete. Up next is the Scriptable Object, which is a location node in the world. An enum of cardinal directions is declared. This is used for tracking the player's facing direction, and each location node has 4 directional views. The structure holds the sprite for the view and a reference to a forward exit, the Scriptable Object. Create Asset menu gives us a menu to create our Scriptable Object in the inspector. The Scriptable Object has 4 of these structures, one for each direction, so you can see how they connect. A direction can lead to a new location, similar to how the storybook page is connected, but now we're not limited to a linear path. Think of it as a grid. The location name is internal and I use it in the UI text for debugging. The last member is for a default direction. If we were to spawn the player to a new location, this would be the direction we'd want them to face, but we use it for when the location is first loaded. After that, the game manager tracks the player's direction. The game manager handles the overall game state. We use a structure for our cursors, up, down, left, and right, and their corresponding hotspots. Our game manager will be a singleton, and if you're asking what's that, a singleton is a special kind of object that ensures there's only one of itself available globally at all times, often used for things like game managers or audio controllers that need to be accessible from anywhere and usually persist across different game scenes. 4 serialized fields are declared for the starting location, which is a scriptable object, a UI view display image, transition effect, and UI location text. The UI view display image isn't used since we have the transition effect, but I left it in. The code is below that shows how to use it. Flags for knowing if the transition is happening. Delegates for the transition state change and its start and finish. Subscribers will tap into these for event notifications. A flag to know if the initial content has been loaded. The current location and tracking the player's facing direction. Mouse cursors to use based on the structure above. These are set through the inspector. And a public bool whether the player input should be accepted. Input is ignored while a transition is running. In Awake, we implement the singleton pattern, get the transition effect, set the mouse cursor to default, and update the transition state. In the start method, we try and load our start location scriptable object. It should be set in the inspector. Load location sets the current location and facing direction, then calls update view. Update view gets the current directional view from the player's perspective. The commented code is for the serialized UI image field. If you wanted to remove the transition, you can uncomment this block, assign a UI image in the inspector, and comment out the if-else block below, where display immediately and start transition are. The UI text is updated with the current location and facing direction. Finally, if this is the first view being shown, we display the image immediately, otherwise the fade transition is used. The next 4 functions are for the player to move forward in the world and make turns. If a transition is in progress, we do nothing and exit the functions. Move forward will get the current view and see if there is a forward exit. If found, the next location is loaded. The turn functions calculate the new facing direction and update the view. Get current directional view returns the view based on the player's facing direction. Get opposite direction does what its name implies. It takes in a direction and returns the opposite. North is south, east is west, etc. Set cursor applies the given mouse texture and hotspot. Can move forward returns a bool. It gets the current directional view and checks the reference to forward exit, which if it's set, it'll be pointing to the scriptable object location that we can move to, returning true, otherwise false. The last two functions have to do with starting the transition effect, managing the state, and invoking the delegates. The player controller is very short. We try to reference the game manager, singleton, and awake. In update, we test the flag if we can accept player input. If no transition is running, the keyboard input is allowed. The up arrow attempts to move the player forward. The left, right, and down arrows change the player's direction. The last script is a screen zone click handler. We define an enum for all the screen zones. The class has range sliders for the zones and they're available in the inspector. The side zone widths, forward, and turnaround zone heights. A variable to reference the game manager and the current screen zone. In the start method, we try and reference the game manager. In update, we have two functions, one to detect which screen zone the mouse is in, and the other for any clicks. Handle mouse zone detection gets the current mouse position and screen dimensions. The code calculates if the cursor is in a zone and remembers it. When it gets to the end, it compares its memory against the current zone. If they're not the same, the zone is updated and the cursor texture and hotspot are applied. And that happens in the function below, update cursor based on zone. A switch case is used on the zone to find and apply its corresponding cursor definition through the game manager. The final function, handle mouse click, tests the player input flag. Left mouse clicks may pass through when no transition effect is running. Depending on the zone, the move or turn functions from the game manager are called. I know that was a lot to digest. In short, the game manager is where most of the activity happens. The transition effect does the fade, the scriptable object creates a piece of the world, and the player controller and the screen zone handler use the input methods from the game manager to navigate the world. The mouse cursors also come from the game manager, and the screen zone handler sets them according to the mouse position. It's finally time to build the virtual world. In the Locations folder, right-click and we'll find the Scriptable Objects menu, Directional Location. You can see it has each cardinal location and they accept a sprite and a reference to the next location. I'm going to create the world and come back and explain how it works. The world has 23 nodes. I constructed it so that there's a loop and 2 dead ends. I used number locations, like L01, L02, etc. You can use your own naming convention. If you have a large world, it's best to draw it out. Connect all your nodes with their associated directions. Think of it like building a map. Here's a bird's eye view of the world with all the locations. Since there literally is no north, I consider moving north as going up. If my map was to begin with moving right, then I would consider that going east, and so on. This map begins at L01 and moves north. That goes to L02 and then continues north to L03. When I get to L04, I have two choices. I can continue north or turn left and go west. You can see the decision points of L04. That splits to L05 and L14. Then L09, that splits to L10 and L23. The locations of L01 and L13 are the dead ends. Hopefully that visual helps you understand how the nodes are related. Let's move on to attaching the scripts. On the Game Manager object, drag over the Game Manager, Screen Zone Click Handler, and Fade Transition. For the Game Manager script, set the L01 scriptable object to the starting location. You can leave the view display image empty since we're using the transition effect, and set the location text. For the mouse cursors, we'll use the system cursor for the default, so no changes on that. Apply the other cursors on their hotspots. The top left corner of the texture is coordinate 0, 0, and the bottom right is the texture's width -1 and its height -1. The Screen Zone Click Handler script will use the default values, 20% for the top of the screen, 40% for both sides, and 15% for the bottom. On the Fade Transition script, assign the image 1 and image 2. We'll use a 1-second duration. Attach the Player Controller script to the player object. Let's play the scene. You can see the mouse cursor changes when it's within a designated zone. If we turn right, the up arrow won't show here because there is no forward exit on this view. If I click on the bottom, I'll do a turnaround. The text location updates so we know where we are and which direction we're facing. You can turn it off by disabling the text object. It's time to explore. I wonder what hidden secrets Polygon Isle has. Oh, there's a portal, but we can't get any closer. Bummer. I'm going to backtrack to L04 and head west. Here at L15, we have to turn right to continue north. L19, we have to turn right and head east. At L23, we connect up to L09. And that brings us to the end of the video. You learn how to build a graph of scriptable objects to construct a virtual world and navigate through it using your mouse and keyboard. Good job. This is Game Dev with Tony signing off. I'll see you in the next video. Take care.